All right, ladies and gentlemen, we're going to be talking about a new section, which is going to be this Unit 2B, and we're going to be talking about parallels and perpendicular lines. Now, the section that I'm going to be focused on is going to be this Day 7 stuff, and it's showing here that there are two different assignments that are associated with it, the Unit 2B 7A and 7B. Now, just notice that the 7B one is just a little bit more practice on this because being able to name these particular angles is going to be the key to being successful in doing these kind of problems. So we're going to roll down here and let's kind of talk about some parallel lines and some transversals. Now, this lesson 7.1, our goal is to come up with some new angle pair names. We've seen some pair names in the past, but now we're going to talk about some new ones. Now, a line, what they're going to give you is it's going to describe this picture right here. A line that intersects two or more other lines at two different points is called a transversal. Okay, that's what it is. This is called a transversal. So if I should label this as T and Q and R, this one right here that's labeled as the letter T happens to be what's referred to as a transversal. The words transversal, broken down, basically means that it traverses, it crosses the two individual deals. Now, as soon as you end up getting this line that ends up crossing a couple of other lines, it generates a whole bunch of these angles that are listed in here. Now, I'm going to number these out. I'm going to be like 1, 2, 3, 4, just going around that one, and do the same thing here, like 5, 6, 7, and 8, something like that. There's 8 different angles that are going to be formed here. Now, in the past, we've actually talked about some of these angle pair names that we've seen in the past. Now, if I point a couple of these out, you'll probably remember what those are called. So like if I said 1 and 3, now those are on opposite sides of the X, and those would be referred to as vertical angles. Okay, now this is an old idea, something we've seen in the past. I'll put here angle 1 and angle 3. Though that's a combination that would be a vertical angle. Another maybe vertical angle combination could be number 5 and number 7 around a different point on this guy. That would be a vertical angle as well too. Now that's one of the topics that we've seen in the past. Now another one that we've possibly seen, and I'm going to erase those arrows so they won't get them confused. So like erase these. What if I picked a couple of angles that were right next door to each other, like next door neighbors, like these? Those two, since they make a straight line or they make 180 degrees, would be an example of supplementary angles. Okay, so we've got a combination of angle 3 and angle 4. That would be a supplementary pair. They could even be ones that are side by side like this, right next to each other, that make a line. And that would be like, say, angle 6 and angle 7. Now, these things that I just discussed right here, these are all stuff that we've learned in the past, stuff that we've done in the past. But what I really want to focus on today is talking about some angle names that we've never seen before. Like maybe we're a combination of something like number 4 and number 5. They're like in different spots. They're around, one of them is around one coordinate and one is around the other coordinate. Now those have their own special name and you're like, wow, what should we call those kind of things? Well, that's going to be our future names that we're going to talk about today. And those future names, there happen to be 4 different kinds of them. So that's where we're going to move towards. We're going to try a couple of future names for this particular next part. Now, for us to get this under control, the key to it is to understand location. All right? So these first 2 that are listed right here, it says there are 4 blank that lie in the region that is between the actual 2 lines. Not the transversal, but between the 2 lines. Well, that would be this green area right here, or the interior. Things like angle 4, angle 3, angle 5, and angle 6. Well, those are definitely what I would think as being called interior angles. They're inside or between the 2 angles. Well, if that's just the case, we've got a blue area that's on the other side, and those would be referred to as the exterior angles. Now, just this association of what is inside and what is outside would be a really good, helpful indicator of which ones I'm basically shooting for. Okay, now I'm going to do these a little out of order, and the reason behind that is because I think that sometimes there are certain ones that are easier than other ones. All right, well, we're going to keep using this picture, and I'm going to go to these two next. All right, now let's read what they have to say here. We're going to try and find the name for our non-adjacent interior angles. So I'm underlining that, saying that they got to be on the inside. They lie on opposite sides of the transversal. So what we're looking for is a pair of angles that are inside and are on opposite sides of the angle. So if I would say, okay, 4 is definitely inside, and what other one is on the opposite side of the transversal and non-adjacent, meaning not connected to it? So this one over here would be the other. So a combination that would fit this description would be 4 and 6. That would be a combination. Now there'd be another set. That could be this guy, number 3, and this guy, number 5. Angle 3 and angle 5. Now, we got to come up with a name for these. What would be a reasonable name? Well, they are definitely on the interior of the deal. So I think they've got an interior name, but they're on opposite sides of the transversal. So we don't call them opposite interiors. We call them alternate interiors, because alternate is just another name for the word opposite. Now, if you can do that same concept with ones that are on the inside, you can easily do that same concept with ones that are on the outside, like 2 up there, and on the opposite side of the transversal, the number 8. So those would be a combination, number 2 and number 8. Or if you wanted another one, maybe number 1 and number 7. Those would go together. And it makes sense that we would probably call those not alternate interiors. We'd call them alternate, I just use ALT, exteriors. Okay, pretty simple ones, right? Got the idea? Which ones are alternate interiors and exteriors? Brand new name. Okay, now I'm going to go down to this bottom one, and I don't know why they do it in this funky order. We're going to go to this bottom one down here at the bottom. What if I was trying to find an angle name pair, but they lie on the same side of the transversal and on the same side of lines Q and R? Now, this particular one right here, I think the best way to understand it is what I would call a slide concept. Okay, now really listen to what I have to say here. If I took this point right here and I could grab it, like say I was on Microsoft Word, and I just reached down here with my pen and I grabbed that particular location and I picked it up and I slid it down until it was right over the top of this point, and then I snapped it in and it just went blink like that and stuck on there. The 5 would land or slide right on top of the 1. It would be in exactly the same location. Or if I was talking about the 6 would slide onto the 2. These kind of angles, and we'll kind of write those down, 1 and 5, and 2 and 6, are referred to as corresponding angles. Now the key here is that you got to remember that they have to be on the same side of the transversal, but they slide. Slide, same side. That's kind of the easiest way to remember it. Okay. Now, probably the toughest one to remember is the one that I kind of skipped in the middle of these notes. And it happens to be this guy right here. And it happens to be that they're interior angles that lie on the same side. But the key here is that they don't slide. I'm going to put here, no slide. Now, they've got to be interior ones, but they don't slide where they're supposed to. the 5 would not slide onto the 4. They're on the same side and they're both on the interior, but they're not a sliding combination. So that would be angle 4 and angle 5, or angle 6 and angle 3. These are referred to as consecutive. Okay, now these two sound a lot alike. Corresponding and consecutive sound a lot alike. The key here is to remember that if you say the word same side, you know that it starts with a C. Okay, that'll get you that far. And then you have to remember that sliding ones are corresponding and non-sliding ones are consecutive interiors. They usually refer to them as consecutive interiors. Okay, now that's what we're going to use as our angle names. Now here's what we're going to do for a little bit of practice. In this particular part, we look at each one of these combinations and figure out what they're going to end up being. 1 and 5. Now if you have to point at them, it totally helps. 1 and 5. Now those are definitely on opposite sides of the transversal. That's that transversal right there. So it's definitely got to be an alternating concept. And they're both on the outside. So that's why they'd call them alternate exteriors. Okay, again, let's point at a couple of other ones. Let's see if I did 6 and 7. 6 and 7. Now they're on the same side of the transversal, so it must start with the letter C, but do they slide like they're supposed to? No, they're not working. That's a no slide combination, so they're called consecutive. If I was going to do, say, 2 and 4, 2, 4, same side of the transversal, so it must start with the letter C, but do they slide where they're supposed to slide? Yeah, that would be the corresponding. This is the slide kind, okay? And then last but not least, I'm going to erase some of these ones here so we don't get them mixed up. And what if I was dealing with 2 and 6? 2 and 6. Oh, well, those are on opposite sides. Those would be alternate, and they're on the inside, so they'd be alternate interiors, okay? Now, I did all those and kind of explained them as I went. Here's your turn to practice. Try these 4 that are listed right down here, and I'll do them for you in just a second, and you can see whether or not you did them right. All right, now here's the answers that you're basically looking for. 3 and 7. 3 and 7, both on alternate sides, both on the inside, alternate interior. 5 and 7, sliding into that spot, corresponding. 4 and 8 on opposite sides of the transversal, alternate exterior. And 2 and 3 on the same side, but they don't slide, and that would be consecutive, right? Now, best way to get good at these? Practice. You have to practice to get the concept under control. Okay. Now, what we're going to talk about here for just a second is going to be relatively quick. And this quick concept is basically saying, well, if we're going to talk about angles, maybe once in a while, those 2 lines that you drew and then cut by the transversal turned out to be parallel lines. Okay. Now, parallel means that they just don't, they're just not random lines. The 2 lines never intersect one another. And to make sure that we can draw that correctly, we would put on the parallel lines a filled in triangle, noting that those 2 things will never intersect one another. That's the parallel symbol in a picture. If you wanted to write it out, you'd be like JK's line and LM's line are parallel. Well, you'd hate to write the word parallel in here, so we have a symbol of 2 vertical lines, and I'm sorry that they're not perfectly vertical. That is the symbol for the word parallel. Okay. Now, you could have 2 lines that don't intersect each other, but they go in different ways, but they'd be in 2 different planes, like one plane above the other. These are referred to as skew lines. Okay. They're not quite parallel, and they don't get the same idea as what's going on. And then it says blank are planes that don't intersect. Well, that would be parallel planes. So you could have parallel planes just as easily as you can have parallel lines. Okay. All right, now why is this parallel idea coming into play? Well, the reason why it's coming into play is because as soon as you get these two lines to lock in and be parallel, it has a tendency to make the actual angles start to look like they're the exact same size as each other, or they have relationships to each other. And that's exactly what happens. As soon as the lines become parallel, let's say angle 5 was 110 degrees because it's looking obtuse, it actually turns out that its slide partner, its corresponding partner, looks like it's the same size. Well, it just doesn't look it. It is the same size. And that's because the parallel lines forced it to actually happen. So in this particular case, you'd be like, oh yeah, I know 5 and 7 are corresponding angles, but what I could really say about them is that they are congruent. So there's a congruence concept that's going on here. Now, key thing to remember is that you have to have the parallel lines to be able to use that. Now, what you can use that for is really actually a lot of powerful concepts. Like say for this guy right here, it says in the figure, angle 5 is 72. Well, if I ever give you anything, that you should put it in the picture, 72 degrees. And then it shows that the lines are parallel to each other. And now I can start to maybe draw some conclusions. How big is 4 in comparison to 5? Well, since the lines are parallel and this one slides to the exact same location, how big would 4 be? 72 degrees. It'd be exactly the same reason. Now, my reasoning would be because they are corresponding, or the corresponding postulate or theorem that you just saw up above. Now, if I was going to say something about angle 2, I'd be like, how would I come up with a value for angle 2? Well, it looks like it's 72 as well, which is a pretty decent answer. Whoa, it's drawing on me. Stop. Stop. Oh, man, look at all that mess that I just made. Okay, it would be 72 as well. Let's go back to the drawing here. But the reason behind it may be a different reason. It's not because it's corresponding, but it's because between 4 to 2, they were vertical angles. So you can come up with lots of different postulates or theorems that explain why they work. You got some brand new ones, and you even have some old ones. Okay? Now the cool part is that your brand new ones that you guys learned, the 4 brand new ones, all happen to have the same kind of concept too. So I want you to look at them. This is the alternate interior concept. Well, both of those look like they're obtuse. And since there's parallel lines that are associated with it, those obtuse ones would definitely be the same size. So alternate interiors are congruent as well. I'm going to skip the guy in the middle. I'm going to go down here to alternate exteriors. Look at 8 and 6. Do they look like they're the same size? Well, the parallel lines are going to force it as well, and those are going to be congruent as well. Now, the reason why I skipped the one in the middle is because the consecutive interior one happens to be like 1 and 2. Now, there is no way that this one, which is obtuse, and that one, which is acute, are exactly the same size. No way, okay? But what you can say is that angle 1 and angle 2, they add to equal 180. So this particular one has a different property, and it adds and equals 180 degrees. They're supplementary, okay? Now, the hardest part about this is trying to keep straight which ones are equal and which ones are add to 180. So what I always do is I draw a little chart. Okay, now this chart is going to be the absolute biggest help to you in this section. Okay, you're going to have ones that fall onto the congruent side, and you're going to have ones that fall onto the add to 180 side. Well, which ones were the congruent ones? The alternate interiors and the alternate exteriors were equal to each other. That meant that they're the same size. The sliding corresponding one turned out to be an equal concept too, but it was only the consecutive one that ended up turning out to add to 180. Now I'm going to add the other two past ones that you've seen in the past, and that would be vertical angles, and vertical angles are equal, but supplementary angles add to equal 180. Now that chart right there kind of basically gives you the idea that if you can name it, you can actually come up with the concept that those things are relatable to. So here we go. Let's try and see if we can put that concept to work. So if I said, hey, here's angle 1 is 118 degrees, maybe I should be able to find any one of the other angles. Well, let's see here. Angle 1 is related to angle 2 because Creek and Reading are parallel streets. How big would number 2 be between Park and Reading? Well, it would be 118. And that'd be because those two are alternate interiors. And the alternate interiors have to be the same size. Now, if I was talking about his next door neighbor, 2 to 4, there is no way those are the same size, but I could come up with 4 saying that angle 4 would be 180 minus 118, or better yet, 62 degrees, because those two are supplementary. So see, you have names to help you explain why you're coming up with those values. Now, what if I was talking about 4 compared to 3 way over there? Well, if this one was 62, this one would be 62, and the reason would be because 3 and 4 are alternate exterior angles. So you use your angle name as your reasoning of why this little chart actually works. Okay? Now, if we want to move this to the idea of how do we come up with the values of some variables, maybe if we need to do a little algebra, well, the key to being able to algebra is to be able to write an equation. And your equations in this case are really going to only end up one of two ways. They're either going to be a congruence concept or they're going to add to equal 180. So you're like, man, I just got to decide what the relationship is. Now, some of these might not have an angle name that's directly relatable. Here's 4 and here's 1. Now, there isn't a name for this one. This one has one inside and one outside, so they're not alternate. But maybe what I could do is if I wrote down that this one was 85, I might be able to find another one that's relatable to it. Well, if I looked right next door, the number 2 one is related to that 85. Those are supplementary angles, which would make this one 95 degrees because they have to add to 180. Now there's a direct connection between 2 and 4. That is a sliding concept or corresponding, and corresponding ones based on our table from up above are equal to each other. So whatever I got for angle 2, 95, would be equal to whatever 4 is, which is 2x minus 17. And look, you got your equation. You're ready to do the algebra. There's nothing wrong with that. You'd add your 17 on both sides, and you'd end up with 2x is equal to, oh man, that's a lot I'm adding. 12, and I gotta carry the 1, and 10. It's 112. Is it 112? 10? 112, yeah. And then if I divided that answer by 2 on both sides, I would get x is equal to, my brain hurts. Is it 56? I think it's 56. There you go. All right. But the key was find out what you're dealing with so you know how to set it up. Now I'm going to point at some other ones here. Let me erase my picture right there so I get all those other junkatos in there. Let's get rid of those. Let's point at some angles and see what we got. I'm going to use this color because it's rainbowy. Here's 2. Here is 7. Ooh, 2 and 7. And those are not a direct relationship to each other. But I bet you 2 is the same as 8 because they're vertical angles, right? So now I'm really could be relating 7 and 8 to each other, and those are consecutive angles. And based on our chart up above, consecutives add to 180. So 4x plus 7 added to 5x minus 13 would equal 180 degrees, and you're off to the races. Okay? So if the relationship's not there directly, look a little bit harder at what other things it's possibly the same as. 5 and 3, I think, are a little bit better. I don't know why I went up to that picture. Maybe I shouldn't have. 5 and 3, oh, look, these are right here. Those are non-sliders, so they must add to 180 because they are consecutive. So that answer would be 68 plus 3y minus 2 equals 180, and you're off to the races to solve for y. Okay, it's because they're consecutive, and that would be your reasoning. All right, I hope that video helps you with lesson 7. Your job in lesson 7 is to do the 7a followed by the 7b because you need the practice. See ya.